Hey, welcome back. So this is going to be our fourth and our final design of our little grapple system we got here on our tractor that we're building. If you remember in the last one, we found ourselves a cylinder, and it was that cylinder 65 millimeters in diameter, and it had a 450 millimeter stroke. Okay, so that's the cylinder we found. We found out this cylinder set up in this arrangement would give me the proper amount of crushing force with, if I remember right, 3000 psi. We're all set up. The only thing now we need to do is design how fast this loader opens and closes. And another very important feature is speed of a hydraulic system. So if we've got this cylinder, this set length, and I want it to go, I actually went out and I kind of figured out how fast I wanted this to move. I don't really care how fast it opens. I want it to be fast as I can get it open. It can be quite violent. Closing, I want a little bit of control. So I kind of did a little bit of testing, and I came up with, I want it to run at 1.4 to 1.8 seconds from fully open to fully closed. I think I'm going to have really good control with that. What we could do is figure out how much flow we need to put into the barrel end, because I want this to be on close. I'll just write close in there. I want how much oil, how fast the oil has to flow into this cylinder to make it closed. The problem with that is, again, we're using the same hydraulic pump that the rest of the backhoe uses, so that means I don't really want to change the flow, and I know I'm going to have to put in a bigger pump than what I need to get this to work. So the other thing I can do is make the cylinder shorter. And that's, I think, what we're going to have to do. So this is what I'm shooting for. I had 25 gallons a minute coming out of my pump, and that's what I'm going to need to do my math on. How long will it take, or how long does the cylinder have to take for that much oil to enter into it to get it to close in time? So let's go ahead and start doing that. The first thing I need to know is how much volume is in the barrel end of the cylinder. Now, we figured that out in the previous videos, so if you want to learn how to do that, go ahead and check that out. So I think what I want to do is, I got gallons a minute and my cylinder's all in metric. I need to convert into imperial or into metric. I think, well, let's just go into, we got the cylinder all figured out in metric, so let's figure this out into metric as well. So 25 gallons a minute equals how many liters per minute? And there is 3.78 liters in every gallon. So 25 times 3.78 equals 94.5. We'll just call it 95 for easy figuring. 95 liters per minute. Now, our cylinder was 65 millimeters in diameter. We know a liter is 1,000 cubic centimeters. So let's go and change this into centimeters. So we'll just go 6.5 centimeters times 6.5 times my stroke length with 450 millimeters. So change that to centimeters times 45. That's my formula set out there. And of course, we got our constant, 0.7854. 0.7854 times 6.5 times 6.5 times 45 equals 1,493 centimeters cubed. Liters here, cubic centimeters there. Let's change this into liters. Divide that by 1,000. 1, 2, 3, 1.49. We're just going to say 1.5 liters right off the bat. So that's how much volume my cylinder holds in the barrel end of the cylinder, and that's when we're concerned about wanting it to get to there. So I'm going to get rid of this math real quick. It's kind of making a mess, isn't it? Now we got a few ways to figure out how long it's going to take that 95 liters a minute to fill 1.5 liters. Two ways I'm going to show you how to do it. 95 liters per minute, the way it's written out there, is like the same as this, as 1 minute. So 95 liters, that would equal the same thing as 95 liters over in 60 seconds. Exact same thing. If I divided those two, so 95 divided by 60 equals 1.58 liters every second. So my pump is delivering 1.58 liters every second. My cylinder holds 1.5 liters. So if I want to know how many seconds that's going to be, I can just estimate it at just under 1 second, or I could do the math on it and go 1.5 divided by 1.58, the amount of liters I need by the pump flow rate per second. 1.5 divided by 1.58 equals 0.95 seconds. Again, we're just under a second. There's another way we can do this as well, and I like to do this way a little bit better. I find it a little easier to do. 95 liters a minute equals 95 liters every 60 seconds. I want 1.5 liters, but I don't know how many seconds that's going to take. This here is a ratio, and this is a ratio. I'm going to put seconds in here. So I want this ratio to equal that ratio. So all I have to do is something called cross multiply. I have two knowns on each side of the equal sign and only one known on the other side. So all I do is multiply the two knowns together and divide it by the side that has the unknown on it. So I'd go 60 seconds times 1.5 divided by 95. 0.95 seconds. You get the same answer either way, whatever way you prefer or you like to do it. I like to cross multiply, but whatever works for you, doesn't matter, you get the same answer. Golden. Now this is a little bit too fast for me. So that means I've got to have a little bit of a difference going on here. So let's do a little bit more math here. I'm going to get some room. I'm going to split the difference and go 1.6 seconds, kind of shooting for the middle, and if I miss a bit, hopefully I'm still in my range. 1.6 seconds. I know I'm getting my cylinder volume in 0.95 seconds. I know my cylinder volume is 1.5 liters. I don't know how big my cylinder needs to be to get it in 1.6 seconds. So I want this ratio to equal this ratio. Again, we've got a side with two knowns and a side with only one known. So multiply the two knowns together and divide it by the one known. So 1.6 times 1.5 equals, divided by 0.95 equals. I need my cylinder to hold a volume of 2.5 liters of oil. Volume equals area times length. Okay. The area, we don't want to change the area because that's part of our force calculation, and we wanted that 65 millimeters worked out good. So I want to know the length of it. So if I take this area and put it over on the other side of the equal sign, so volume divided by area equals the length of my cylinder I needed. Again, the area is going to be in centimeters squared. So let's figure out what our area was again. 0.785 4 times 6.5 times 6.5 equals. Our area is 33.183 centimeters squared. My volume, we have it in liters, but we can't work liters in centimeters squared, so let's change the liters into centimeters squared. All we can do is times it by 1,000. So move the decimal place 3 points, 2,500. And this is centimeters cubed. So if I go 2,500, not that many 2,500s, and divide it by 33.183 equals 75. Now centimeters cubed divided by centimeters squared, it'll be centimeters are left over. 75 centimeters long stroke. So my cylinder was 450 millimeters. I need to make it 750 milliliters or 75 centimeters, and my cylinder will extend at the right length or the right speed at the right time. So I just cut the ends of the cylinder off, buy a longer tube, and build my cylinder a little bit longer. May have to lengthen the rod a little bit. We'll see how it goes. Now that seems like it might be a lot of work. And in real life, I think what I would probably do is simply stick in a flow meter in the system. So when I pull the grapple down, I keep that shorter cylinder. The grapple moves at the right speed that I want it to. Now that's up to you. Flow meters cost money, but so does tube and labor to go into building the longer cylinder. So whatever's easier. But that's how you do the math, and our grapple is officially what do you call it? Designed. Now just the hard part of making it come to life. We're done with this. I hope you found it interesting. Shoot me a subscribe if you like. I'll be coming out with other videos, hopefully a lot more interesting than this. But until next time, thanks for watching.